this particular concept. So here, if an object is in second quadrant, then I can say that it is behind vertical plane and above horizontal plane. Remember, this is an imaginary process. We are purposely keeping the object away from the plane of projection. And very important thing in first quadrant is object is in between observer and the plane of projection. In second quadrant, plane of projection is in between observer and the object. So you see this object and represent its image in the plane here itself. Not in the previous case, there is no other planes here. So in such conditions, you are going to solve the problem. So what will happen here also? Here also you are supposed to, in second quadrant, to represent the 2D drawing, I have to rotate this horizontal plane in clockwise direction only, because it is according to a particular standard we are doing this. If we are not doing in such fashion, again and again, first quadrant only will be repeated. So same answer you will get with respect to, if you rotate the horizontal plane in anti-clockwise direction, you will get vertical plane above, horizontal plane below. So there is no use. So we are imagining that it is in second quadrant and representing its view. So if a point is in second quadrant, so how how well these images will look. So that is what we are going to see now and represent in three-dimensionally. So in representing three-dimensionally, we will see how to we'll imagine that imagine a second quadrant. So in second quadrant, I'll imagine a point like this. In second quadrant, this is vertical plane, this is horizontal plane, and I'll consider a point here called as capital B. The point B is behind VP and above HP. Then obviously it is in second quadrant. So what I'll do is I'll directly take a particular problem and then try to solve it. So in a sense, we'll take a problem like the point B is 20 behind VP and 30 above HP. Draw its projections. So in second quadrant, how you are supposed to assume and what is the distance from XY line we are going to see, and XY line is the intersection of HP and VP. I'll consider this as X and Y, and I'll start representing the, and I need the final answer. I need only the final answer here. These imagination will run in your mind. So I'll imagine the problem. The point B is 20 behind VP and 30 above horizontal plane. Draw its projection. So something, a question may be like this. The name of the point is capital B and it is 20 behind vertical plane. See, this distance from B to vertical plane is 20 You can imagine an object which is lying at a 20 distance behind the board. If you are sitting in a classroom, behind the board a wall will be there. Behind that wall a classroom is there. Imagining like that in second quadrant and solve the problem. So in second quadrant, behind vertical plane, I have got a point which is located at 20 distance. Next, 30 above HP. This distance above HP is 30. This is not dimensioning. I am marking the distances. This is 30 and 20 So always remember this quadrant. Observer will be on your right, plane of projection is here, and object is here. I'll get the image in the vertical plane itself. So before the uh, object itself, I'll get the view. So I'll get the view here. As I'm seeing, the observer is seen from the right. So I'll get this view, the front view here itself. So I'll name it as small b with a dash, which is called as a front. Similarly, object is seen from the top and represent its top view. This is the top view and I'm as B. So what is the distance of B dash from XY line? This distance is, what is this distance of front view from XY line? Can anybody unmute and inform?
30 mm.
30
Yes,
mm.
30. Similarly, distance of top view from XY line, how much it is?
20 mm.
20 mm. I
20
hope
mm.
the video is clear and you're able to see it. See, forget about this image. Your problems will be given in a statement wise. This is the statement given to you in second quadrant. At point B is 20 mm behind VP and 30 mm above HP. You can imagine any chair which is in second quadrant also. But before drawing a chair or an object, we have to learn from point. That is why we are starting from points. So you have to imagine second quadrant, keep this point in second quadrant and convert it into a 2D drawing. So 3D imagination should run in your mind. So 3D imagination should run in your mind. This is your 3D imagination, three-dimensional imagination. Nowhere you are going to write this particular drawing, but this should run in your mind in the later days or wherever you are going to answer. So as a complete standard, I have to convert this 3D concept to 2D drawing. This 3D concept or the words that are given in 3D or an imagination that is given to you as a question should be converted into an answer in a 2D. So how to convert that? I have to rotate the horizontal plane in clockwise direction. I have to rotate the horizontal plane in clockwise direction. When I rotate the horizontal plane in clockwise direction, this horizontal plane and vertical plane will overlap with each other. I will just represent in different colors. This horizontal plane, if I rotate, whatever the image is there here, everything will be overlapped with vertical. This horizontal plane is turned up to vertical plane. So what will happen? Directly, I am going to draw a line and represent it as x and y. When I rotate this, these lines what I have drawn, vertical plane and horizontal plane, it does not have any exact boundary. So I'm just leaving it as it is. So I'm represent vertical plane from a horizontal plane both above. Somewhere in this region you have got vertical plane and horizontal plane both above XY line. But what will happen in first quadrant? First quadrant, vertical plane will be above, horizontal plane will be below. In second quadrant, both are overlapping above XY line. So first is 20 on the same projection line. I am going to draw a point, I don't know, at a distance of 20 for two boxes. And from here, 10 mm, I am going to draw one more point and name it. So at from XY line, at a distance of 30 mm, you have got B dash. See, this is B dash, so front view. At a distance of 20 mm, you have got B. And dimension 20 and 30. See, this is 20 mm and this is 30 mm. At a distance of 30 mm, you have got the front view. At a distance of 20 mm, you have got the top view. This is what second quadrant answer means to. What I'm informing you is a three-dimensional statement is converted into 3D view imaginarily, and I have to look here where these projections are coming, where these projections are coming at what distance. 20 mm behind VP, 20 mm behind VP, that 20 mm distance, which is the term is associated with vertical plane, but it is seen on horizontal plane only. This 20 mm is seen on horizontal plane. So top view without a dash, only B, small letter B will be the top view. That is what second quadrant says. So directly I am drawing the same figure in sketchbook. So this is my rough sketch. Whatever problem given to you, draw a rough sketch like this, then convert it into final answer like this. Or in examination, we'll get an empty sheet on the left hand side. You can draw here and then a rough sketch here and then convert it into particular answer here. So I'll just draw 20 and 30 means 3 boxes I need. So at the fourth box, I'm just going to draw a line, and from here till here, a thin line, not necessarily of what any thickness. I'll represent it as x and y, and as it is second quadrant, I'll represent it as VP comma HP. Both are above XY line. Why above XY line? Because it is in second quadrant and rotating the horizontal plane in clockwise direction. This whole HP will come to a straight line on a single plane, so that I can see both the views. So from 20 for two boxes, I'll draw a projector. See, as it is a point, why I'm drawing this projector on the same line, how I got the answer, because it is a point. Point is an impression without dimension. It will not move towards the right or left. Where if you draw a straight line from B dash to XY line, and if you continue down there only, the top view will lie. So we discussed in the same in the previous class. 20 mm, and again from here just for 10 mm from the top view, I'll draw on the front view. Just put a dot like this and name it as B dash and B. So dimensioning very important. This line, this projector line is a thin line. Dimensioning is very important. So first dimension, I'm going to mark it at a distance of 10 mm, that is one box. So in between these two 20 mm, I'm going to mark the number 20 here, and 30 mm will be for this box. Around 15 mm, I'll mark 30 because I have to dimension this. So dimensioning, as there is a printed line, I need not have this set square because this is a printed line here. There is a printed line here. I'm going to draw extension line and draw this dimension line 30 as well as here 20, and mark the arrow mark very clearly. Thirty and 20. So what is this? Top view and front. Any doubts here? Please discuss, anybody. This is the final answer that you are going to draw in sketchbook. Directly I'm drawing in sketchbook, not with any other condition. So a point is a three-dimensional concept is given to you. A point B is 20 mm behind VP. So behind VP means 20 mm behind VP. That projection will come on the top view. So B is associated with 20 mm dimension. 30 mm above HP is clearly seen. 30 mm above HP is the height of a person. If you imagine, that can be seen only on the vertical plane. Anything drawn on a vertical plane will be associated with a dash, that is the front view. We are calling it as a front view. That is the B dash. So there this concept lies. You draw a rough sketch, convert it into 2D as a 3D, and then convert it in 2D and then draw it as a final answer. If you don't have sketchbook, you are drawing it in unruled book like this. Name it properly, XY capital letters, VPHP capital letters. Any doubts in second quadrant? Anybody? Let us see the difference here. This is the difference between first quadrant and second quadrant. First quadrant, what is happening? Vertical plane is above, horizontal plane is below. Second quadrant, vertical plane and horizontal plane both are coinciding above XY line. So let us see in the same way. I'll write a problem and then solve the same condition. Point C is 40 mm behind VP. Please write down the problem and solve it immediately. If you got a scale and pencil, at the end of the session, I'm ask anybody to uh, unmute your video and show me the answer wherever you are writing. It should be a constructed answer, not a rough sketch. Constructed answer, either it can be in sketchbook like this or an unruled copy, but you need to use scale and pencil. And this type of dimensioning, first 20 and then 30, is called as incremental type of dimensioning. You need to maintain the same fashion. Next, third problem. The point C is 40 mm behind VP and 30 mm. Can anybody continue the problem? And for third quadrant, the point C is 40 mm behind VP and 30 mm
below
below HP.
30 mm below HP.
Below HP, draw the projections. And state the quadrant in which the point lies. It can be called like this. I'll draw a 3D figure. Okay, horizontal plane. Vertical plane and horizontal plane, and I'm going to place a point here. This point name is capital C. Observer will be on your right always and from the top. So what is going to happen? Let us see. Where it is. This is a three-dimensional concept that is running in my mind. I want the final answer. That's all. So 40 mm behind VP. So behind VP 40 mm from VP. This is the distance 40. 30 mm below HP. From here it is 30. So if I see the object now from the front view, before only I'm drawing this and naming it as C dash, and here also before only I'm naming or seeing the object and then naming it as C. So what should happen according to the basic concepts of projection? I have to rotate the horizontal plane in clockwise direction. Remember, horizontal plane is rotated in clockwise direction always. What will happen? I'm rotating this horizontal plane in clockwise direction. So horizontal plane will come above and vertical plane will come below. If I rotate from XY line, if I draw an XY line, horizontal plane will be above and vertical plane will be below. Vertical plane will be below. Consider this as just I'm differing it with different color. Horizontal plane will come above, vertical plane will come below. Whereas in first quadrant, here in first quadrant, vertical plane was above, horizontal plane was below. In third quadrant, horizontal plane will be above and vertical plane will be below. So let us see what will happen to the projection. So I'll draw a final answer. See, I am telling you why I am drawing like this is this there is no boundary like this. Just I am representing two planes. It can be an infinite boundary. Representations and views of an object is important, not the planes. So planes are imaginarily we are keeping that this is a particular location, and we need some references to keep uh, some objects and represent it. What do you mean by references? Means, for example, uh, in cricket, if you imagine how six distance is measured, for example, 98 meters or 102 meters, 105 meters, 68 meters, something like that. If a batsman hits the six, there is some uh, distance given to you. So, what is the distance? It is from the point where the ball has started its projection, from the starting point where the batsman is hitting the ball. From there to the stands where the ball lands. So from that distance is 98 meters or something like that. You cannot identify any distances without a particular reference. There must be some 0 point. So that reference, we are giving some references by this horizontal plane and vertical planes. So there is no definite boundary for this horizontal plane and vertical plane. I'm representing like this. Horizontal plane will come above, vertical plane will come below. So on horizontal plane here, the C distance from XY line, this distance is 40 and this distance is 30. So on four boxes here, I have to draw a point and name it as small c, and from here three boxes and name it as C dash. So this is your final answer. Top view will be above and front view will be below. Whereas in first quadrant, front view will be above, top view will be below. This is the major difference. So final answer, how to draw it is draw XY line somewhere here. XY, HP and VP. To represent that till here, it is 1 mark. Please remember, step by step marks are there. Annotations and namings will consist of 2 marks. XY line, if you name it in capital letters HP by VP for this problem, if you represent, that means you have got 1 mark. So next is four boxes. 4 boxes directly. I'm marking a point here as C, and 3 boxes on the same line I am going to represent and draw a thin line. Next, perpendicular lines are drawn to this line here as well as here, and mention the dimension 40 just exactly at the two box. I am going to represent half of the total dimension, and somewhere here I am going to represent 30. Whatever dimension it is, answer remains same. So make sure about the answer, that is which is very very important. Anything else. So even if I change it to 10 and 20, the answer remains same. So that is the importance. So this is top view. This is front view. This is your final answer for point in third quadrant. Any doubts, please inform, because it is very very important. First quadrant and third quadrant, very very important. We'll be continuing with first quadrant and third quadrant, and why not fourth quadrant. I'll give some examples also and explain the same cases. So any doubts, please tell me. Object which is lying here and then representing the front view and top view. Similarly, object is lying here, second quadrant, behind VP and above HP. Similarly, what you are doing here, I want this 3D concept to be converted into 2D. If it was first quadrant like this, I'm rotating the horizontal plane like this and identifying its front view and top view where it comes like this. Similarly, second quadrant, I am rotating the horizontal plane in clockwise direction. If I want to see this view, these views, top view and front view, I cannot directly represent in 3D. So I have to convert it into 2D. So I am rotating this in clockwise direction. So what will happen? This horizontal plane on the left side, this horizontal plane and this vertical plane are coinciding. This when I rotate like this. So horizontal plane and vertical plane will be above XY in second quadrant. Same way in third quadrant, remember in third quadrant, here third quadrant, HP and VP is there. When I rotate the horizontal plane in clockwise direction, HP will come above and here VP will be below. This is vertical plane will be below. In third quadrant, remember in third quadrant, this is HP, VP. Same VP, I'm going to write here vertical plane and vertical plane, horizontal plane and horizontal plane are written here. Third quadrant, when I am in third quadrant, when I rotate this, horizontal plane will come above and vertical plane will come below. So we'll see the applications also of these things after completing this fourth quadrant and complete this fourth quadrant, which is very simple, and let us finish it fast. So a point B is 20 mm below HP and 30 mm in front of VP. So I will draw a 3D figure for fourth quadrant. For fourth quadrant, horizontal plane and vertical plane is like this. We place a point. This is the observer who sees the point and sees the front view. Observer sees from the top and represents its top view. So let us see what is the distance. 20 mm below HP. This is 20 mm below HP and 30 mm in front of VP. 30 mm in front of VP is the distance from XY line. This is 30 and this is 20 XY line from XY line. This is capital D, this is small d and small d dash. So when I convert this to XY line and rotate the horizontal plane in clockwise direction, both VP and HP will come below XY line. So here from XY line at a 20 mm distance, what is there, and at 30 mm distance, what is there? This is important. At 20 mm distance, you can see the front view, that is the D dash, and 30 mm distance, it is nothing but the D. The D is the same D which comes when you rotate this whole plane in clockwise direction. Complete projections will come here and it overlaps. So directly draw the fourth XY, VP, HP, both below 20 mm and 30 mm. And 30. I'm going to draw these dimensional lines. So you please re-log in again. So see, this is a simple example of point in first quadrant, second quadrant, third quadrant, and fourth quadrant. When a point is in first quadrant, vertical plane will be above, horizontal plane will be below. So I'll just take an example of a book. Here, if you take a book, if you consider this as a first quadrant, horizontal plane is rotated in clockwise direction. Some views have come. Horizontal plane rotated in clockwise direction, you get vertical plane above, horizontal plane below. Same way, if this is in second quadrant, when I horizontal plane is like this. So when I rotate the horizontal plane, both VP and HP will overlap above XY line. Same way in third quadrant, if I use the any line in third quadrant, when I rotate the horizontal plane will come above, vertical plane will come below. Similarly, in fourth quadrant, it will overlap below XY line. Below XY line, both the planes are overlapping. Both vertical plane and horizontal plane are overlapping like this. So if I rotate the horizontal plane, both planes, vertical plane and horizontal planes are overlapping below XY line. That means all the views are overlapping below XY line. So most of the problems that you solve will be VP will be above, horizontal plane will be below. If this is XY line, VP and HP, both the planes will overlap above XY line. If this is XY line, HP will be above, VP will be below. And similarly, XY line, VP and HP both will overlap below XY line in fourth quadrant. Let us see some examples. For example, we'll take a okay, television as an example and explain what will happen in first quadrant. In, if I draw in first quadrant, the front, I am not drawing as it is an infinite space and imaginary. I'll just draw front view and top view. I'll just draw the front view and top view of a television set. I hope you can understand. Next, in first quadrant, if you keep the object in first quadrant, this will be the answer. If you keep the same object in second quadrant, front view and top view will overlap. This is the top view which is overlapping in second quadrant. Whereas in third quadrant, you get the top view first and then front view below. In fourth quadrant, front view and top view are overlapping below XY line. So most of the cases in any manufacturing process, we will be using only first quadrant and only third quadrant. We are not using second and fourth quadrant for any object to be imagined, which is this is very essential. Anybody can ask you about uh, what are the four quadrants, what is why we are not using second and fourth quadrant is also a very important question, interview question, and what how well you are going to understand the basics is very important. Please unmute yourself and discuss any doubts if you have got. This is an example of a television set I have taken. I can take a mobile phone also. Just imagine a mobile phone. If this is the front view of a mobile phone, somewhat like this, and the top view is like this. In third quadrant, if you keep it, top view will be above and front view will be below. This is the major difference in first quadrant and third quadrant. Don't say that it is not mobile phones are, of course, I'm just representing images to make you understand, that's all. Any doubts, please discuss and for about all these four quadrants. And simultaneously, we have started with points. The very first chapter, we imagined a point to be in first quadrant and continued with. So that is why we are discussing all these things. So same way, this is called as We are calling it as third angle projection and first angle projection, whichever type you are imagining and representing an object, whether it is a mixer grinder or a mobile phone, you are supposed to mention it clearly to the manufacturer so that he will understand it and implement it in his manufacturing techniques. So that is why we are learning all these things and implementing the same in further representations. Anybody who has not understood about these four quadrants, please unmute yourself and inform me immediately because it is very very important. Anybody? Lakshman Nayak,
Yes, sir.
understood?
Yes, sir. Understood.
Suma, Suma, yes. Who is it? Suma or Sumant? Please log in properly. Others, Pandey, Manojas, Eunice, Kishan, Ravchecker, Yamuna, here. Who was logged in as 112 FAB COC? Yamuna, here.
Sir,
Any doubts? Have you understood the concepts
yes, sir. Um,
about all four quadrants? Bhumika,
Yes, sir. I understood, sir.
Nishant Gowda. Okay, might be very boring it seems. I think so, and most of them are not interested, I guess. And let us continue with whatever the thing it is. Uh, Even if it is one person listening properly, I will be ready to teach the same thing. And see, this is the basic concept of a projection of points and consider it to be here. It can be a plane surface, solid, or whatever it is. I considered an object here where front view and top view will be represented here. If it is vertical plane and horizontal plane, this is the front view. and top view obtained here. Same way, front view and top view will be in the above horizontal, above XY line. Similarly, top view will be above and front view will be below. This is the top view, this is the front view that you are seeing of an object. And here both top view and front view both will lie below XY line. So this is the front view and this is the top view that you have obtained. So this is the case of all these type of projection, four type of quadrants, but we are not following all the four. We are following only the first angle projection and third angle projection only. So third angle projection most of the European countries and other countries will do. But first angle projection is the only projection that ISO standards, according to these standards, we will be using only this first angle projection only. So yes, Eunice, anything important? Have you understood? Eunice,
Yes, sir. Yes, sir.
have you understood all the four quadrants?
No, sir. First one, not.
Huh? See, these are the four quadrants in which you are imagining the objects to be and representing its views. In first quadrant, you get some front view and you get some top view. In order to convert it into a 2D drawing, you are supposed to rotate the horizontal plane in clockwise direction. So when you rotate the horizontal plane in clockwise direction, you get vertical plane above, horizontal plane below. Same way, if you rotate in second quadrant, both the planes will be above XY line. Same way in third quadrant, if you rotate the horizontal plane, then horizontal plane will come above XY line and vertical plane will come below XY line. And similarly, in fourth quadrant, below XY line, both vertical plane and horizontal plane will coincide. That means front view and top view will coincide above XY line in second quadrant, below XY line in fourth quadrant. So second quadrant and fourth quadrant we are not using. Only in points there is some difference between the two and we are getting some particular images. So but not in projections of uh, the other type of projections in other cases. So in first quadrant and third quadrant only we'll be using these two quadrants for further representations. So any representations that you imagine to should be considered in first angle only and in third angle projection only. You need to read as and when you read the problem, you should be able to represent and write the answer. So we'll continue the next problem in projections of points when there is